Great. Okay, so let me get started. Hello, everyone. My name is Minko Gechev. I'm working on Angular at Google. Today, I would want to share with you a couple of updates on what is new in Angular, where the framework is heading, and what are some of the biggest new features that we released over the past couple of months. We have been talking a lot about generally how Google supports Angular, but we haven't been talking much about how Angular supports Google. And it's pretty interesting to see how Google pretty much runs on Angular from within the company. In order to open a ticket and process it from there, you have to interact with a lot of Angular systems. First, if you open an issue because you found a bug somewhere, or you want to work with support team in different organization, you have to file a bug by using a platform that is developed in Angular. It is called Buganizer. This is our issue tracking system. If you want to look up some source code in our mono repository, which has a couple of billions of lines of code, you're going to interact with a view called Code Search. That is, in fact, an open source project that is implemented in Angular again. If you want to edit some source code, you're going to use a text editor, which is somehow similar to VS Code, but implemented internally for entirely our custom purposes. And I believe it also precedes VS Code that is implemented in Angular as well. And finally, if you open a pull request, or internally we're calling it a change list, to the mono repository where you have updated a bunch of source file, your colleagues and you are going to interact in another platform called Critique that is used for just reviews of these change lists that is implemented in Angular again. These are only a couple of the projects that we have implemented in Angular within Google. In general, I believe there are over 2,800 applications, and they vary from small internal apps, for example, cafeteria applications, as you see, to some mission-critical apps, and also some quite massive public-facing applications, such as Google Cloud Console. This is one of the biggest Angular applications that I'm aware of. It has at least a couple of millions of lines of code within it. Another example is Firebase Console, which is pretty massive as well. We also have Google Domains, Google Analytics, and many others. And there are quite a few developers who are working on these applications on a day-to-day basis. Only the developers within Google are altering quite a lot of code. We have about 1,000 engineers who are using Angular on a day-to-day basis every month. And we have over 1,000 engineers taking the Angular course annually. This is part of the internal story for Angular, for first party, the way we call it, or for Googlers. So a good question is, why are we even bothering to make Angular open source, right? Because it is so well utilized within Google and it is so mission critical within the company. Well, there are quite a few interesting points that are allowing us to not only build the technology, but also give back to the community. For example, hiring. If we are able to make a technology successful and it is widely available outside of Google, it will be easier for us to hire people who are qualified to join all these enormous projects and these exciting applications and contribute back to them within the Google monorepo. Ecosystem, that is one of the biggest advantages, I'll say. Before joining the Angular team, I was contributing a lot to the Angular ecosystem in different ways. And these contributions were useful not only for the broader Angular community, but also for developers within Google. For example, one of the tools I developed before I joined Google, called Codalyzer, was already in use within Google for linting all this source code that we have within the company. And this is only one of the examples. There are many other third-party modules that are widely adopted within Google. And this way, Angular can also be part of this ecosystem. We could contribute to the community by developing the framework and all the surrounding tooling infrastructure. And this way, we benefit not only within the company, but also for the external world. Feedback is an essential part of it. We have the source codes openly available on GitHub, so anyone can look at it and provide us feedback on what they find to be wrong in it. For example, security vulnerabilities, or even styling improvements, or even documentation. And this way we can make the framework better together. And quality. That's pretty much a subset of the practices that we already discussed for feedback. Now, I want to specifically focus on the ecosystem for a second. As I mentioned, this has particularly sentimental value for me because before joining Google, I was contributing to Angular for maybe 5, 6, 7 years. I was building different tools, and for me, it was a great pleasure to be part of this extended Angular family, to be participating on Angular conferences, to be speaking on Angular podcasts, to be building tools for developers, and to be getting feedback from them. So the adoption in the open source community, we recently noticed that we originally had about 1.4 million downloads at the beginning of 2020, I believe. Currently, we're with over 2.5 million weekly downloads. So this is a pretty significant growth for a span of a year and a couple of months. I believe we're about 100K more weekly downloads, so the statistics might be a little outdated. And currently, Angular is used, Angular Core, I mean the framework, is used by over 1.8 million projects on GitHub. These are only open source projects, so we're not counting all the production applications out there. A couple of these applications, some of these applications are just modules for developers. Others are production-grade applications that you can look into and explore their implementation so you can grow your Angular toolset, Angular skill set with you. Here is an example from Trung Vo. He implemented feature-complete Spotify clients in Angular that you can use in order to listen to music. And his application is available on GitHub, so if you want to see how he implemented it, you can just follow the GitHub link and find everything that he used, understand the state management, understand the different coding practices he used, and so on and so forth. This is a really great case study for how you can build an Angular application that is with certain production characteristics. It was a great pleasure for me, in fact, to collaborate with Christoph here. Christoph was part of the research team in Harvard. They were building an antiviral drug for COVID. This was early in 2020. They were using Angular for visualization of their research data. They built this Angular application that is still available on GitHub, that you can look at its source code. And this is another example of the impact that this larger ecosystem could have, not only on the Angular community, but also in the world. And Manfred is one of my very favorite community members. He has been an Angular GD for a while, and he has been focusing a lot on the enterprise use case, where people are building large-scale applications, and they need a level of tooling to support their scalable development. He has been working a lot on module federation and variety of different practices, including differential loading that he contributes to Angular CLI. And the ng0 team, we have been collaborating closely with them on an implementation of an image component that helps you bring closer to better Core Web Vitals. Core Web Vitals is a set of practices that allows you to ensure that your application, allows you to actually measure that your application performs well in terms of user experience. There is a set of 3 practices: cumulative layout shift, largest contentful paint, and first input delay. In particularly here, we worked together with the ng0 team on improving specifically largest contentful paint and cumulative layout shift by efficiently loading and preloading images with server-side environment. So as part of this effort, we're part of the Web SDK, or Project Aurora in Chrome. Project Aurora aims to help different frameworks from within and outside of Google to implement improvements for Core Web Vitals so that can provide better development experience and better user experience for everyone out there. With Project Aurora, we implemented an improvement on top of largest contentful paint. This was one of the metrics that was giving sometimes regressions in the score, even though the applications were implemented in an optimal way, specifically around server-side rendering and the hydration of the view in there. So we iterated with their metrics team, in Chrome, and we were able to come up with an implementation that doesn't penalize Angular and other alternative technologies performing similar way of destructive hydration of the server-side render view. We worked together on inlining of Google fonts, and we're going to include Adobe fonts next. And we also implemented an extraction and inlining of critical CSS that can further speed up your applications, specifically around largest contentful paint. If you're interested more on how Core Web Vitals and the improvements that we did are helping customers, you can read this case study by Crunchbase on why they made the transition to Angular. But generally, they have quite a few users coming from organic traffic, and in combination of Angular with our server-side rendering solution Universal, they're able to continue this trend and even decrease the serve time significantly compared to their original tech stack, where I believe they were using Rails, and now they're using Angular with Universal. All right, so let me talk a little bit about what's new in Angular version 12. As usually, we're working towards modern standards and simplification. This means that we're deprecating some old technologies that are no longer in use after we got in touch with community and asked for your feedback. Right after that, as usually, we have a couple of feature drops and new tooling. Let us start with modern standards and simplification. So as part of modern standards and simplification, we run a RFC in order to see what would be the people's feedback on the deprecation of IE 11. We noticed that the majority of the community was pretty excited that we're going to move forward from this ancient technology. And so we deprecated IE 11 as part of Angular version 12, and we're planning to remove support in version 13. The second thing that we did as part of version 12 is to deprecate View Engine. So in Angular, we had a couple of different rendering pipelines. We had View Engine prior to version 9, and now we have Ivy. That is the new rendering pipeline and new compiler that produces smaller footprints for your generated source code. We deprecated View Engine so that we can remove some of the legacy code and also to transition the entire ecosystem to the new format so that anyone can take advantage of the features that we're introducing for Ivy only. For deprecation of Ivy, we had a look at the statistics for usage of the Angular CLI. So when folks are creating new projects with Angular, they can specify whether they want to enable Ivy or disable it. By default, Ivy is enabled for all applications out there, but if you want to opt out of Ivy and use the previous rendering pipeline, you could specify the enable Ivy flag and set it to false. We noticed that almost nobody opted out of Ivy, so we decided that it is a safe move for us to assume that View Engine is not going to create trouble if it's being deprecated. So we have this two-step deprecation practice here, like process. First, we remove the enable Ivy flag because we assume that most people, over 99.9% of people, would prefer to use Ivy anyway. We also enabled the Ivy library distribution formats. This is a way for people to distribute libraries in an Ivy compatible format. And the second part of the process would be to start distributing Angular framework and the rest of our packages that are consumed as libraries in Ivy format as well. Here, the need for this is that if we have a View Engine library, it wouldn't be able to depend on an Ivy library. So we want to make sure that we allow libraries to transition to Ivy first before we move our fundamental building blocks, such as Angular framework, to the new packaging format. And now let me talk a little bit about features that we introduced as part of the framework's latest release. A couple of things that we introduced first as an opt-ins were Webpack version 5, the Ivy language service. This is pretty much support for text editors and IDs that is relying on the Angular Ivy compiler. We worked on way better error messages. So now if you hit expression has changed after it was checked, or rather than seeing only this error, you're also going to see a URL associated with Angular IO. When you click on this URL, you're going to open the error page, which also has a video associated with it where you'll be able to understand what this error is all about and see a couple of different ways you can fix it. We're working on resource inlining. I already mentioned the critical CSS inlining and Google font inlining. This was part of the collaboration with Project Aurora in Chrome, and also introduced Tailwind support. Tailwind support was a very highly requested feature by the community, so we managed to introduce it without necessarily adding Tailwind as a dependency, but still providing native support if the dependency is in there. All right, so all of these features were pretty much implemented before version 12, but most of them were opt-in features that you wouldn't be able to use unless you set a specific configuration flag. This has been our approach on rolling out major features. We just want to try the waters to see whether people love a particular feature and if it works in a good way, contributing to their productivity or the performance of their applications. And if we notice that there are no significant complaints, we just enable this feature by default. We have been pretty successful doing this with Webpack and with resource inlining. So a couple of features that we introduced in version 12 specifically are inline Sass. Inline Sass has been one of the very highly requested features. So if you have a very small set of styles that you can directly want to inline in your component and have a single file component, you can do that now. Knowledge coalescing is another feature that was introduced as part of ECMAScript 2020. And now we have native support for it in Angular templates. We enabled production builds by default. This doesn't mean that when you run ng-serve, your build is going to be production. No, it's still going to be development. But if you run ng-build, or if you run npm run build or yarn build, you're going to get a production build. This is way safer for folks because, unfortunately, we have seen a lot of development builds in production, which is very suboptimal. And also, it provides us better interoperability with platforms such as Vercel, Microsoft static sites, Azure static sites, excuse me, and also with services such as Firebase and Netlify, where it will be way easier for folks to just use the platform's knowledge about the npm scripts, and rather than specifying extra flags, they'll be able to just run npm run build, and they're going to get the production assets by default. We did the same with strict mode. So now the TypeScript compiler will be a little bit more explicit. For example, when you don't specify a type and you have an implicit any, or when you don't initialize an input. This may make the compiler a little bit louder, but at the same time, it provides higher guarantees that your program is correct, and also provides us more type information when we want to perform an automated update as part of the ng update experience. And we did quite a few changes in our end-to-end testing experience as well. So we have been using Protractor for a while, but over time, the entire ecosystem moved. When we developed Protractor in the first place, we didn't have things as async await, so we have to develop a workaround for this. Now, with the language evolving and the entire web ecosystem generally moving forward, we decided that Protractor is probably not the most future-proof solution. So we collaborated with different end-to-end testing vendors, such as WebDriver.io, Cypress, Test Cafe, I believe, and Nightwatch.js. And we worked on different builders that integrate well with the Angular CLI and provide a reliable end-to-end testing modern experience. A couple of community contributions that I want to highlight, because Angular is an open source project, and we're not only getting contributions in terms of feedback, but often even in terms of pull requests with features. So these are adding extra functionality on top of interceptors. There are improvements in forms by Sonu, further improvements in forms by Mike, and app initializer with observables. This is from Yadong, the maintainer of ng0, who made sure that you can run some extra piece of logic before you initialize your Angular application and wrap this piece of logic in an observable so that when it completes, Angular will move forward and initialize your app. But before that, you wouldn't have been able to do that. App initializer supported only promises. And the major release that we run as part of I/O 2021 is Angular DevTools. So Angular DevTools is a Chrome DevTools extension that allows you to preview the structure of your application and also profile its performance. Angular DevTools is something that we didn't focus too much on in the past because we had a community solution called Augury. But with the rewrite of the framework by using Ivy, we opened a couple of new debugging APIs that were providing an opportunity for better insights into the runtime of your applications. So we collaborated with Augury and their development team at Rango.io and implemented Angular DevTools that is currently available in the Chrome Web Store. It currently has over 55,000 downloads for the first month. So if you're interested in understanding the execution of your application, feel free to check it out. I just want to highlight that this would have definitely not been possible without everyone from the community helping with the framework. I was looking at only at the Angular framework repository, which is on GitHub. That is github.com/angular/angular. And we have over 19,000 pull requests from people. That is a lot of pull requests. A lot of them are from the team, clearly, but many of them are from community members. And we have merged the vast majority of them. We have some weird merge scripts that are cherry-picking commits rather than merging commits with the traditional way GitHub does them. So some commits might be marked as closed, but they're generally part of the code base. So they're not really closed. They were merged as part of the monorepo. And it is just really exciting to be part of such a fascinating, active community who is constantly trying to make web better. Thank you very much for your attention today. I would really appreciate your feedback about my talk at mgv.io/talk. And I believe we still have time for questions. So if you have any questions, I'd love to answer them.
It's a great session, Minko. We really enjoyed the new features of Angular and the news of Angular. A lot of people are asking what does Angular have features more than React, and React why? So can we list some features Angular have and not included in React?
Yeah, well, I'm not a React expert. I have used React in the past for my startup, but this was 4 years ago. So I'll share from my point of view here. Although I believe you can be successful with any of these technologies. So with Angular, we're aiming to provide more of a platform. We're not providing only a framework. Our team has been working also on the CLI. We have been working on it ourselves at Google. We're also providing a set of UI components and primitives, such as the Angular CDK, where you have a bunch of accessibility utilities that are built into our tooling that you can use directly, and they're well integrated with the framework. And also, I mentioned the CLI already. So these are some of the distinguishments, I'll say. There are also clearly very big differences on how you're performing change detection and how you're updating the DOM. I'm really happy with the way we're doing that with the compiler because it is very memory efficient and pretty fast. But I'm also clearly biased. So.
Yeah, that's great. So anyone also have questions here? Okay, so thank you, Minko, for this great session again. we, we are very happy to have someone like you. And so